You know, often when we think about mobile communication, mobile apps, we frame it in the sense that it gives us superpowers. The ability to access any information in the world at any time, the ability to never be lost, the ability to call up an image anytime you need it. But what we sometimes forget is that for some people, there are abilities that they don't have, that we all take for granted. And so I'm moved by Marita's presentation because it shows me that our technology capabilities can also be used to improve the lives of those who are less able and bring them up to par with other people. And so I think that's a really powerful illustration of injecting humanity back into this discussion of technology. Now we're going to move from the topic of telepresence to the topic of augmented tele-existence. Our next speaker is a professor of human-computer interaction at the University of South Australia. He's working right at the interface of the virtual world and the real world. And he's worked with a number of different technologies, mobile technologies, augmented reality, wearable computing, and so forth. He is Mark Billinghurst, and I'm looking forward to hearing what he has to say about mixed reality technologies. Welcome.
Hi there. So as Robert said, my name is Mark Billinghurst from the University of South Australia. And at the beginning of today, Robert talked about how one of the themes was the blending or disappearing of the barrier between real and virtual worlds. And that's what I'm really going to talk about today. So about when I was born, this was the state of the art of computers. This is an IBM 1401. In 1967, these computers comprised half of all the computers in the world, and they cost about $10,000 a month to run, so about the price of a house in 1967. And of course, in the 50 years since then, we've seen this trend towards a disappearing computer, where computers gone from room size to desk size to our laps, and then in the palm of our hands and in our pockets. But the way we use computers, oftentimes, even though the computers are getting smaller, oftentimes create this artificial separation between the real and the virtual world. So here's our traditional desktop interface, and you can see there's a distinct separation between the digital space and the physical space. And what we want to do in computing technology is get rid of that and make the computer entirely invisible. And there's a number of ways you can do that. We've already heard this morning from Robert and others talking about Internet of Things, and you can embed sensors in your environment that make the computer go away. You've got your Alexa speaker, and that's connected to cloud services, and the computer itself is invisible. But the technologies I'm really excited about, though, is virtual reality. And you can see with virtual reality, you basically replace your reality with computer graphics, and in that way, the physical computer, again, has become invisible. And if you do it right, you can create a really compelling experience. So let's look at this video here.
Open your mouth and shock.
So is it too big for your head?
I'm holding it tight.
What do you?
She's good. She's good. Did you get the picture of her doing that?
I'm taking a video. This is going on YouTube.
Oh, man.
So this is some guy's grandmother who's trying virtual reality for the first time. And that combination of immersion, interaction, and imagination creates a really, really powerful experience. And again, makes the computer invisible and immerses you in the technology. What we're doing at the University of South Australia is working more in the augmented reality space. And you may not be aware of this, but the University of South Australia publishes more research papers in augmented reality than any other university in the world. So we have this kind of hidden gem here in Adelaide that we can really draw on. And with augmented reality, unlike virtual reality, you're trying to blend the virtual images with the real world. So you see the icon on the top right-hand corner, you're still interacting with the real world, but your interactions are mediated or blended by computer graphics. So here's a nice example of a spin-out company I helped from New Zealand a couple of years ago. They're called Quiver, and you can go to McDonald's and you can get the McDonald's tray mat and you can colour it in, and then using their free app you can look at the tray mat and bring it to life with augmented reality. So you can see they've coloured in there, they bring their phone up, they look at it, and now this little character appears, and the character takes the colours they coloured themselves. So kids love this. This is a free app you can download. Just look on the App Store for Quiver or Quiver Vision, and you can have now interactive experiences on real objects. So that's a very simple application of augmented reality, and what it shows is the three defining characteristics: being able to combine real and virtual objects together, being able to have interactive content in the real world, and most importantly, have that virtual content appear like it fixed in the real world, so the dancing character appears on the McDonald's playmat. So with those three technologies, Internet of Things or ubiquitous computing, virtual reality, and augmented reality, they're all different ways of making the computer invisible. What really, but there really can be put on this continuum from the real world to the virtual world, depending on how much the computer generates of your space. So on the right-hand side, you've got virtual reality because the computer's generating everything you see. On the left-hand side, with IoT devices, they're pretty much invisibly embedded into the real world. And this continuum is often called mixed reality. Paul Milgram came up with the idea, and he said it's anywhere between the extrema of the virtuality continuum, so anything between the real and virtual world. And what we're really interested at the University of South Australia is looking at how we can use mixed reality technology to build next generation teleconferencing experiences. So in science fiction, we oftentimes see this. If you've seen the Star Wars movies, you would have seen the Jedi Council, where this guy who's light years away appears as a virtual blue person. Or when they're making phone calls in Star Wars land, you can see the Sith Lord appearing in the palm of the hand of his general. And there's been movies made. So this is the Lawnmower Man from the 90s, where both people come together in virtual reality and conference together. And we can see the technology starting to appear in commercial applications. Facebook, a couple of years ago, released the Facebook Spaces, and this is a way to bring avatars together into the same virtual space. So you can see in this video here, there's two people, and this guy grabbed a ball, brought it towards him, and now transported himself to a part of London, and now he can draw a little tie, puts on the other person can draw a bow tie on him, and they can take a virtual selfie together, and of course if they drop it in that little box there, it posts the selfie to Facebook. So this is a way people who are far apart can come together in the same virtual space and collaborate almost as easy as if they were in the real world together. You can do the same thing with augmented reality, or some of the things with augmented reality, and one of the particularly exciting areas of augmented reality is using augmented reality for remote collaboration, which lets you see through somebody else's eyes and puts virtual content into their space. So for example, a couple of months ago, Microsoft released their Remote Assist application, which runs on the HoloLens augmented reality display. And the use case for this is, you can imagine you're in a factory, a piece of equipment breaks, and you don't know how to fix it. So if you put this headset on, you can make a call to a remote person who will help you, and then they can put virtual lines and drawings in the real world to help you. So I'll show you an example of that. So you see the person in the factory here?
Or what you do, collaboration is the key to success. When challenges arise, you need the right people with the right expertise. But bringing people together isn't always easy. And travel is not always an option. With Microsoft Remote Assist,
you can basically start a Skype call and then call a remote person to help her.
With a window into your world, backed by enterprise-level security, your team can collaborate with shared perspective, anytime, anywhere.
Bonjour, Amy. How can I help you?
We're having some issues with our machine in C5. I could really use your help again.
We just updated the manual for these.
So she can upload documents to show her.
This looks like an electrical issue.
She can also draw on the screen and put arrows in the real world. So for the remote person, it's almost like they're there. And for you, it's like having a virtual pair of hands inside your field of view, helping you fix problems. So now they're bringing a third person to the call, and so now they've got a small group of people helping them out. And again, drawing on the view as well. So it's a way you can get remote assistance wherever you are.
Can you try this?
So this is very exciting technology, but at the University of South Australia, we're trying to go beyond this. And one of the limitations with this technology, as you see it, is that the remote person can only see through the camera that you're wearing, and the camera is facing straight ahead, so they can't look in a separate view from where you're looking. So a year or so ago at the University of South Australia, we developed this application called SharedSphere. And in this case, on the left-hand side, you can see a person wearing an augmented reality display, and they're wearing a hard hat, and on top of that is a 360 video camera. So this person then streams video to a remote person who's in a virtual reality display, but they're streaming 360 video, not just a 2D video. And now the remote person can look wherever they like, having a separate viewpoint. On the virtual reality side, this person has some technology that captures their hand gesture, and they can then send the hand gestures back to the other person on the left-hand side. And for them, they get the impression that these virtual hands are floating in space in front of them, showing them how to perform different tasks. So this is a project we're doing in collaboration with Nova Systems and also with SA Power. So here's a video of the system working in power electronics. So you can see a person looking at this control console, and he's trying to diagnose a problem. He's wearing the HoloLens and the 360 camera on his head. And then in his view, he can see this virtual hand appearing that's now pointing at different places in the control panel and drawing on the control panel and showing him how to perform a task. And that green square there, that shows him where the other person is able to see what their field of view is. And then on the other side, on the remote side, in the virtual reality, the person in this case feels like they're standing in the same space. They see the 360 video, and then using their natural hands, they can draw and annotate on the real world. So the impression we're trying to get is that both people feel like they're in the same space together, collaborating together to solve a problem. And this can be really, really useful. The SA Power people gave me an example of a few years ago when they had a power outage at one of their substations, and they get fined by the state government when that happens. So they lost power to 1,000 homes. The person who was at the substation didn't know how to fix the problem. He called for help. Somebody drove out, took 45 minutes to drive there, and fixed the problem in 5 minutes. They were fined $500,000 because they lost power to 1,000 homes for that 1 hour. So with a 5-minute call with our system, they could have saved that amount of money. So that shows an example of using 360 video, but again, that's still not like the real world because you're still showing a video of the real world. So we've gone beyond that and we've added some other features as well. So the existing features are using the augmented reality and virtual reality together, supporting this view independence and supporting view awareness cues so you know where the person's looking, and also having hand gesture collaboration. But within the next 5 or 10 years' time, you'll be able to have some sort of small handheld technology where you walk into a room, push a button, and it will capture a 3D model of the room and send that remotely as well. And so we've been prototyping that. And so here's a project we did with the University of Canterbury in New Zealand. And in this case, what you'll see is a person with a VR headset on, and as they start turning their headset around the world, it starts to capture a 3D model of that world. So you can see in the top right-hand corner, slowly he's building up a 3D model of his workspace around him. And like I said, in the next few years, you'll imagine some sort of technology where they could just walk into a room and immediately capture a 3D model. And now what we can do, instead of streaming a 360 video, we can stream the 3D model to the remote person. And the remote person now can then walk around that environment and feel like they're really sharing the same world with you. So the second video shows an example of that. So you see here is the local person who's got some real objects on a table and they're trying to do some sort of task of picking and arrange objects. Here's the remote person, and instead of seeing a 360 video, they're seeing the scanned 3D model of those objects. And they can use a pointer to point at real objects. You'll see these white lines appearing. That represents the view frustum where they both can see. So now, instead of just having looking at a flat image, they can now walk around that 3D object in real time. And the long-term goal is to be able, you can imagine, for example, in an earthquake, when a building's collapsed, you might want to send a first responder into the building. So if somebody goes into that building, they could use some sort of technology to immediately scan the inside of the building, make a 3D model, send it out of the building to the fire chief or the disaster response chief at the other side, and then be able to have that person go into VR and feel like they're in the same space with you as well. But the main focus of our lab is empathic computing, and let me explain that briefly. So in terms of interface technology, there's 3 important trends happening. So one is towards improved content capture. So we've gone from technology that just take photos of our faces to technology that can scan and capture whole spaces. Secondly, we all know about increased network bandwidth and how you can now have gigabit bandwidth between locations rather than kilobit as it was a couple of decades ago. And finally, we're developing systems that can do implicit understanding. So you can have computers that use cameras and microphones to understand what you're doing or about to do. They can recognize human behavior and emotion. So these are 3 big trends happening in the computer interface area. And where we're trying to work with our lab is at the junction of that space that we call empathic computing. And the goal is, can we develop systems that allow us to share what we're seeing, hearing, and especially feeling with other people? So let me give you a couple of examples of that. The first one is a project we call Empathy Glasses, and this is to enable people doing teleconferencing to have a better understanding where the other person was really looking and feeling. So we combine 3 technologies together, eye tracking glasses, an augmented reality display, and a special pair of glasses called effective wear glasses that could recognize your face expression. And by combining these 3 technologies together in the teleconference, we can share implicit cues like your gaze or your face expression. Cues that you normally use face-to-face very effectively, but in a traditional Skype call, you don't have those anymore, so you don't communicate as well. And this allowed us to build a unique remote collaboration system. So you can see the person here wearing all our gear on his head. In addition, he's wearing a heart rate sensor to measure his heart rate and associate that with emotion. And then on the remote side, this is the view here. And most importantly is the green dot and the red dot. So the green dot is a mouse pointer that the remote person's moving to tell you what to do and where to pick things up. And the red dot is where your eyes are looking. And that's really important because people always look at objects before they interact with them. So if you want to know if somebody's paying attention, you can look at where they're looking. So here's a video of the system working. So here's Young Ho, and he's going to be assembling some blocks on the table there, and then Masai on the left is helping him perform the task. So on his laptop, he's talking with him, and as I said, he's moving this green pointer around, and we can now tell whether he's paying attention or not by looking where the red pointer's going. So you can see as he's moving the green pointer, telling him to put the block there, his eye gaze is following where he's going. And this is really helpful. You can imagine in some sort of remote assistance task, if we're able to monitor where the person's eye gaze is, when they're about to push the wrong button or unplug the wrong piece of equipment, we can know that because they're looking at that piece of equipment before they do it. And there's these special glasses that use photosensors to measure the distance of the skin from the glasses. And so by doing that, measure the face expression. So on the video, you can also see the person's face expression changing as well. So that's a very interesting application of empathic computing technology that changes how we do teleconferencing. Instead of having to tell somebody to do something and wait while they do it, we can now watch what they're looking at and see what they're about to do before they perform that. But this is just part of a bigger trend. And so in the mixed reality space, there's a number of tech trends. So one is towards much more advanced display technology. Secondly, we've got technology for capturing gestures and having richer gesture control. Third, for real-time space capture. So like I said, in the next year or two, you'll have technology where you can click a button and capture 3D models of a space. And there's also eye tracking, and people are now also combining EEG technology with head-mount displays to do emotion sensing and sharing. And so these combination together is something we call Empathic Tele-Existence. And we just saw a really great example of a remote tele-existence, a robot. So here's another example of a product that came on the market a month ago from a company in Japan called Tele-Existence. And this is where they're using VR to put you into a robot body. And you can see by using the head tracking, and also in this case the person's wearing gloves that has a tactile feedback, you can actually touch objects remotely as well. So you really get a strong sense of tele-existence. What we want to do though is move beyond this and not put you into a robot body, but have you go into somebody else's real body and understand what that person's really feeling and experiencing, and being able to share that experience with them. So maybe in the next Olympic Games in 2020, you see the Olympian barreling down the hill on his mountain bike. Maybe I'll be able to sit at home with my VR headset, see exactly what they're seeing through my headset, and also by sharing their heart rate and other gaze information and so forth, we can understand what they're feeling as well. So this is a move towards empathic tele-existence, where you move from being an observer to a remote person to be a participant with them in their life, from explicit to implicit communication, and have more experiential collaboration where you collaborate together. So just to finish, what I've talked about today is I've shown you a little bit about mixed reality and how you can use mixed reality for collaboration, and how, as Robert said at the beginning of the day, how it really breaks the barrier between real and digital worlds. I've also talked about future research directions we're doing at University of South Australia, in particular empathic computing and this trend towards empathic tele-existence. And we're just based here down the road in Mawson Lake, so we'd love to collaborate with some of you. If you want to contact me, there's my contact email address, my Twitter handle, our lab website, and if you email me, I'm happy to send you all the slides I just showed you and the videos as well. So thank you very much for your time.
People join us. I would like to call Marita Chang and also Dr. Philip Alveda to join us, please. So I wanted to gather you all here. The crew's going to come up and move some chairs around, so let's just move closer to the center of the stage while they do that. I wanted to bring you all up here together because I think there's an opportunity for us to have a conversation about how these technologies can combine and work together.
Nope. Where are you going to put that?
Here, chair is on its way. Here, Philip. Yeah. Thanks. So I'm interested in recombinant technologies. That's been a theme of mine, and it's certainly something that keeps coming up. It's like a recurring theme here today. So I guess I would ask you to talk about the different technologies you've shared, and ask you to think about how you might collaborate, how you might share some of the technologies you're working on at Cortical AI, what you're working at the university here, and at what you're doing with Aubot. Philip, what's your perspective?
Well, I think the defining characteristic of the kinds of problems we're trying to solve is that the data is becoming more voluminous, as you had noted in your talk. It's becoming more diverse, different data types, concerning a broader and broader range of complicated problems that all interact. And I think one of the real kind of powerful features of the emerging class of AI technologies that we're developing is that it can really sort through all of these complexities and synthesize useful things from them. And
that's a new thing, because just a few years ago we didn't have that capability.
That's exactly right. And so challenges in education, challenges in interaction and communication, I think is a fundamental target for the types of things we're developing. So the more interfaces we have, the more tools we have to do it. Robotics reaching into the different aspects of interface, improving the controls. I think all of it is, it's a giant system integration and synthesis problem.
One of the things that crossed my mind when I was talking to Genevieve Bell, she kept bringing up the concept that the people doing the programming sometimes encode their biases into the algorithms. That's a known problem. And Marita, when I saw your presentation, what crossed my mind is that it's a chance to teach an AI that there are different types of human beings with different ranges of capabilities. Are you recording that information? Is there some way for you to track that information and feed it into a cortical system like say, Philips?
I mean, like the work we do with iPoly that tracks like everyday objects as opposed to faces. So a lot of the biases are built into the facial recognition systems. Like if you think about like the typical software engineer in the Bay Area, for example, that are training all these algorithms, it's male typically, and so that's why these algorithms get very used to, as Jen would have mentioned, they get used to like seeing men and not seeing women, and seeing a particular type of men and not different type of men, and so they make predictions based on what they know, and so they're more likely to say, oh well, the next leader of this company will be a male as opposed to a woman, because like it's always been a man, so why wouldn't the next one be a man? Right. I mean, with our robots. How much
of that data do you capture? Are you able to? Is your system able to learn, in other words, from the users and their different capabilities? Yeah, I mean, with iPoly, we gather the images that our crowd helps us train, and then we filter through it. And the filtering process is really important, like filtering like rosary beads, for example, or dogs or cats. People like to submit all different kinds of images, we have to be very careful with how we filter and classify them. Otherwise, we'll be training the neural network with imperfect data. Mark, what do you think is next? Like, what do you anticipate coming next?
Well, I mean, in our lab, we're looking at building these empathic Tele-Existence systems. So I'm really impressed with Marita's work and also with Philip's work, and we are very much interested in looking at how we can recognize emotion using some of the types of work that Philip's doing. I noticed that overlap too. And also that with Marita's work, that allows you to have the ability to remote effect in the real world. And what we'd like to do is allow people to really share the experiences of others, so that my elderly grandmother, for example, is too old to go bungee jumping. There's no reason why I can't go bungee jumping and she couldn't have that experience sitting at home on the couch. And I think by doing that, by sharing experiences, it really helps build a stronger sense of empathy between people, and that also gets to what Genevieve was talking about, the sense of wonder. Right, I can experience things at home that I can never experience before. That really helps me empathize with other people.
Yeah, I really like Mark and Jen's point about empathy and like the humanities, because like you can't just create technology in a vacuum without thinking about the end user. I mean, I remember when Facebook came up with their virtual reality thing, everyone was very excited about it, but then it kind of just fizzled out because they didn't think about, well, how does it actually connect people in a way that's really powerful? And I think like what's really exciting is it feels like we're kind of just starting this journey of having people know that this technology is out there and experimenting with it, but it'll still take time for people to figure out how to reliably integrate it into their workflow and into their lives.
And there's really practical application for that as well. I know, for instance, at the at the Film Academy in Beijing, they're using artificial reality to get an entire film crew to understand what the sets are, because nowadays all the movie sets are made with computer graphics. And so it's hard to get everyone on the same page about how you're framing a scene, what lens you're using, what focal length, and so forth. So the best thing they can do is basically teleport everybody into the same virtual room. And you could be in different continents and do that. They showed us a demo of that. I was quite astonished because as a filmmaker, that was a capability that was hitherto unimaginable, right? You know, back in the day, only the camera crew knew which focal length and lens you were using. And so everyone else had to kind of estimate what was happening, but now you can have that shared experience. And that's the definition, I think, of empathy.
And what I like about that is that it saves people time and increases quality of life, because like the film crew that has to be brought from all these different areas, it means they can spend more nights with their family at home rather than going to a remote location where they have to, you know, spend months in a hotel room.
That's true. And people who have limited mobility are going to be able to experience things kind of at a distance, I suppose. Philip, how do these things combine together to make a smarter AI?
Well, I think that one of the big advances in the last decade really is moving from the idea of programming and the fact that the programmer himself introduces a bias in some designs, rather than building a system that is designed to be, to some extent, a blank slate, and will learn from experience. So we talk about unsupervised learning. So the idea is to make a machine that can be put in an environment and then learn from it. So in a way, it's much more like a baby, that it's put into an environment, it kind of absorbs what was around it, and it gets some social cues and direction, but more or less on its own kind of establishes an understanding. The important thing to realize is that whether you're a human baby or you're an AI baby, you can still become biased if you're in an environment that offers you only biased perspectives.
Yeah, that's true. Limited experience is going to shape you in a certain way. I mean, that happens to all of us in the context of how we grow up. What I noticed when I was watching Marita's presentation is I noticed certain patterns. So with the telepresence robots, but also with the AR app that the blind people are using, human beings are inclined to notice certain things. And if you had a learning system, you could have a learning system that would start to understand what human beings pay attention to, and I think that could actually go a long way towards building a kind of imagination or at least a sensory awareness inside of a robotic system. How much automation is a part of what you're working on, Mark? How important is automation?
So we don't, with what we're currently doing, we're trying to enhance the human existing capabilities. So it's more like Fred Brooks, who's a computer scientist from University of North Carolina, he said that we don't really need AI, we need IA, which is intelligence amplification. So what we're trying to do is amplify intelligence. So we don't have a big part of automation in our work, but I'd like to get to that point where we can start looking at more telepresence robots and add more automation into that. But what we're trying to do right now is amplify people's intelligence and especially create an enhanced sense of empathy with other people as well.
I'm thinking if you collected a larger and larger data set, eventually you'd be able to do some predictive analysis. So let's say, for instance, the blind person using the mobile phone, they can't see so well or at all, so they're not going to necessarily be able to aim it exactly the right place. And some of your videos kind of showed that. And it struck me as an opportunity there where a predictive system might be able to nudge the person in the correct direction. Where we're going to kind of help them get to what they're searching for. Well, I'd be interested to hear any other thoughts you might have about this recombinant notion where you can take these three different domains, but overlapping or contiguous domains, how they might interact with each other and accelerate progress.
So I think the thing that's really exciting from our perspective is it's so much easier to do this than it was 10 or 20 years ago. So when I first started doing augmented reality research 20 years ago, it would take 6 months to have a little virtual cube appear in front of you. But now you can just do that in a matter of minutes with existing tool sets. So the very exciting thing is that because the tools are so much easier to use now, it's very easy to do that recombinant work, like you said.
That's right.
Philip showed, you can take the Google TensorFlow library, you can combine it with some augmented reality front end, I can easily combine some robotics, and then I've got some sort of Tele-Existence robot that takes me weeks to build rather than months. So it's really exciting from the perspective of being able to build an MVP really quickly. So encouraging that kind of maker or hacker community where you've got an idea you can put, like with Maria did an amazing job in just 10 weeks building this, or less than 10 weeks building this amazing application for the blind that, if she tried to do that 10 years ago, it was going to be, or 20 years ago, it would have been impossible.
Yeah. Just the vision part alone would have been a stumbling block.
Yeah, and I think a really important, often unsung component of that is the notion that all three of us, university and a couple of different companies, we both have adopted the ethic of open source and open APIs.
That's right.
Where what we develop, we purposely want to make it accessible to collaborators like Mark and the telepresence work and the robotics, that with that openness, you can make that acceleration happen.
We finally started to realize that if your platform is open, then other people can build experiences on top of it that actually enrich the platform, make it better for everybody. Certainly that's true with the learning system, right? Once it's learned, it only needs to learn one time, and then that knowledge can be repurposed and reused and built upon and expanded by other subsequent experiences. I find that very exciting. I find that a good frontier. Well, we're going to take a break now. It's our afternoon tea break, but don't go far. It's only a 15-minute break, and then we're going to come back with some very exciting presentations to share with you. So thank you to my panelists. Thank you very much for your presentations today.